Hello, Marco.
Yes.
I just was asking if there is an interval between the lecture and the panel.
It will be a short one. Like it depends on the discussion, but I think we have it so everything is on the same link. So nobody has to disconnect and reconnect. So we're quite relaxed in this regard. We don't have any limits on the timing. If we start a minute late or two, shouldn't be a problem.
Okay. Well, then when this interval comes, Marco, then I just wanted to test my presentation, okay?
I mean, you can test it now if you want.
I just don't want to interfere because it's already for her. There's no problem. My presentation is there. Okay, when she finishes, I just need you.
Well, it should be better if we test now, because if we idea is to go from invited lecture directly to the panel with 1 minute break. I will try to finish everything in 1 hour. So now you have 3 minutes more for testing, please.
Okay, then you have to let me share my screen.
Yes, perfect, Professor.
Okay, thank you.
Okay,
I'm trying to.
No. I can do it. So, yeah.
Okay, let me see it. Okay, let me do it. Okay. Wow, it doesn't. Oofa, where is it? Okay, here. You see it?
Just make it like a full screen presentation.
Well, for me, it's already a full screen. It's not for you, okay? Yes?
Yeah.
Okay, then. So so I have to put it full screen first.
Yes, and then share.
Oh. Yeah, the problem is that I don't find you anymore.
Use the Alt and Tab to switch to Zoom.
That's exactly what I'm doing. Oh, sorry. Yeah. Here. Yeah. Okay. Opa. So far away. Can you see it? No.
Yes, that's it.
You can?
Yeah, perfect.
Okay. But it doesn't change, does it? No, it doesn't change. Yeah, two different systems here.
You have to click on the presentation and then it will change. But I'm afraid we have to move now with the lecture.
Okay.
So I would ask Professor Vale to put presentation. Okay, it's starting, and now let's see if you can put it full screen. Okay, Marco, I think it's time to start recording and to let the people in.
Yeah.
We start in 1 minute.
Okay. Nevin, do you want to be a co-host so you can see the...
Yes, please.
Yeah.
I need to see the questions and answers and the number of participants and everything. Welcome you to the third day of SDEWES 2022 conference in Sao Paulo that is unfortunately held online. We have here our third invited speaker, Professor Zita Vale. She is a full professor of the Department of Electrical Engineering of the Institute of Engineering, Politecnico do Porto. She works in the area of power and energy systems with special interests in the application of artificial intelligence techniques. She has been involved in more than 60 funded projects related to the development and use of knowledge-based systems, multi-agent systems, neural networks, particle swarm intelligence, and data mining. The main application fields of these projects comprise smart grids, accommodating and intensive use of renewable energy sources, distributed energy resources, namely distributed generation, storage, electrical vehicles, including the ones with gridable capability and demand flexibility. The main application fields of these projects comprise smart grids, accommodating and intensive use of renewable energy sources. Marco, I'm having echo.
Sorry.
Okay. Real-time management and simulation of energy resources, considering electrical networks, buildings, and diverse Internet of Things, and machine-to-machine approaches are relevant aspects of her work in this field. Electricity markets, addressing decision support for market participants, prices and tariffs, ancillary services, energy transactions, service provision, and market simulation in the scope of wholesale and local markets. The integration of distributed energy resources, demand response, and electric vehicles in electricity markets, transactive energy, and peer-to-peer approaches are important aspects of her work. Her work also focuses on the conception, development, and test of new business models for market participants and aggregation models for energy resources and the respective management of operation methods. The results of her research are published in more than 200 journal papers. Professor Zita Vale actively participates in several technical working groups and committees, namely from IEEE. Zita Vale is co-editor-in-chief of Applied Energy, which is one of the journals that SDEWES has a very long cooperation with, and has editing responsibilities in several other journals. She also has regular activity as reviewer and evaluator for papers and for project proposals and monitoring from different funding agencies around the world. Professor Vale, I would like to ask you to take the cloud and present your today lecture in 45 minutes. The cloud is yours.
Thank you. Thank you very much. It's a pleasure to be here. I thank you very much for your invitation and for introducing me. Good morning, everyone. It's a pity that we have to be in the cloud and not in person, but I will try to give you an insight, a motivating insight of my activities and of the concepts, modes, and technological solutions that we have been developing, namely for sustainable energy communities. Just to locate our activities, we are settled in Porto, in Portugal, in our School of Engineering of the Polytechnic of Porto. What you see here is a kind of living lab in building in ISEP campus, and this building is daily used by researchers, around 20-30 researchers each day, and is used for testing our solutions. I will first introduced the energy policy in the European Union. In fact, energy is one of the most important topics nowadays on political agendas, on research, on scientific agendas, and on the professional agendas. It's very important because societies need energy to go on. They need energy for economic development. They need energy for their own comfort. And we need to provide people with the required energy, although we should ensure a sustainable use of energy. So this is an important topic inside the European Union. We can say that the European Union is in fact also an energy union. And we are seeing this at the moment because with the current situation, with some problems with the gas supply, we see that energy is more and more understood as a real good that impacts in a very crucial way our lives. So we have very ambitious goals in Europe. Namely, we have goals for climate neutral, which is a very ambitious goal by 2050. And also we have these goals for clean energy for all Europeans. There is a legislation package which is called Good for Consumers, Good for Growth and Jobs, and Good for the Planet. So this clean energy for all Europeans, dealing with the three different aspects, it really can impact our lives and our economy. So let us see how we can take from this starting point the political willing to solve and to address this problem in an ambitious way and make our work, namely our research work, to contribute to fulfill these goals. We can also look at other international entities and other international agreements. Of course, the world is much larger than Europe. You know that Europe is not rich in energy terms, and there are many areas around the world, namely Brazil, who are much richer than Europe. So, on the other hand, it is not possible to divide the world into different countries when it comes to energy and when it comes to climate, environment. So it is important that we have very large agreements involving the all possible countries that can contribute to this energy sustainability. And in that frame, we have, of course, United Nations, who have been working towards this goal. We have the Paris 2015 agreement. We have regular meetings around this subject, not always with the best possible agreements, but nevertheless with the possible agreements that are helping us to go on and to go on with the best solutions. So I will talk a little bit about energy in these times. And these times are times that we are addressing smart grids and microgrids. Smart grids is a very generic concept, but it is a very important one. Microgrids, on the other hand, are a very, very concrete implementation, a physical implementation that is very important for smart grids. And inside this concept of smart grids, we have a lot of building blocks. Namely, we have to consider renewables, of course, distributed generation, generation that is based on primary sources, which are renewable energy sources. We have to consider storage, because storage is difficult when it comes to power systems. We always have a very low percentage of storage in power systems due to technological, but mostly to economic reasons. And now storage is being used more widely, not only at the utility scale, but also at a distributed level. And also we should consider electric vehicles. We know that there are a lot of decisions regarding vehicles, and that in some years electric vehicles will have a very strong presence in our roads, in our streets. And finally, we should, of course, consider buildings, because most of the time people are inside buildings, and a lot of energy is used inside buildings. So buildings are a very relevant building block for the success of smart grids. So we have to consider active consumers, because the consumers that are inside these buildings or somewhere else, they should be aware of the use of energy. Also, we should consider aggregation, because we are talking here about distributed energy resources. It is important that we are able somehow to aggregate them in order to gain some scale and to be able to come up with good business and technical solutions. Finally, at the end of the day, we need to ensure sustainable systems, but sustainable systems in different aspects. Of course, in the energy aspect, but also in the environment aspect and in the economic aspect. Our goals, as always, are to reduce costs, to increase the profits, and of course, we want in this way to ensure a relevant added value. And with this added value, we must know what to do with it. And maybe the most difficult question to be answered right now is how we should distribute and share this value. In the look for replies, we should look not only at the energy transactions, but also we should look at the energy provision, because power and energy systems require a lot of energy-related service that must be ensured for the efficiency and security of the system itself. We must also look at business models, because this must be sustainable in a market-driven approach. In fact, right now, we should look at the problem not only as a problem which impacts all public life and all people life, but also a problem that should be solved doing the best possible actions and based on market-driven models. So we should look at contracts, tariffs, and so on to go on with the models that are able to help us to achieve our energy goals. And for that, energy consumers, but also energy communities are very relevant. In fact, I believe that we cannot work at the distributed level, at the local level, without organizing some kind of energy communities. Why? Because people are having much more impact on the energy systems than before. Before, the energy systems were mostly centralized, so decisions were centralized. So the utilities could use their own human resources, their own financial resources, their know-how to solve the problems. But now the people's action have a lot of impact on the energy and power systems. And this is why people are so important. And sometimes we have a huge difficulty in considering the models that are related with people. People are seen as citizens when it comes to smart cities, as customers for retailers in energy, as consumers for utilities, but in fact, retailers, utilities, people working in the power and energy field are not used to develop, to conceive good models to address people's behavior and the impact of people on the system. We must address demand flexibility, we must address demand response, this meaning the way in which the demand flexibility can be delivered to the system or to third parties. we must consider local generation, local storage, electrical vehicles, and all the distributed energy resources. And in fact, communities are already considered important in the European legislation. I have here some text from two different directives, one directive from 2018, the other from 2019, both addressing energy communities. In one case, they are called renewable energy communities because renewable resources are very important. In the other case, they are called citizen energy communities because this aspect of people being citizens is so important too. In any case, if you look at the European directives, what we can see is that they are quite ambitious. I must say that in 2019, when I saw this directive 944, I was quite pleased because in fact, it shows that we can now go we can go forward and apply many of the models that are really helpful to ensure sustainability. So let us consider these communities, consider the local generation that is based on renewables, consider also the self-consumption. Consumer self-consumption was not a reality till some years ago. It was not considered legal in many countries. Now it is being considered not only legal, but very useful. So we should work with it. We should work with demand flexibility and demand response. We should consider peer-to-peer transactions, transactions among neighbors, and of course, different kinds of organizations, namely local energy markets. So we have new opportunities. We have the opportunity to share our resources, noting that sharing does not mean sharing for free. We can still have benefits for the sharing of our research. We should consider these peer-to-peer transactions. We should consider transactive energy and new organizations and markets, namely the aggregators, local markets, and energy communities. And of course, we are having a lot of operation data coming from the new players and new organizations. And we should study and have solutions for the good application and good use of those data. So I would say that we need real-time decision and action because we should keep the lights on. The physical system is still there. The physical system, I mean the electric grids, all the substations, they are the basic support for all these power and energy business. So we should consider the physical models of the infrastructure we have, and we should ensure the real-time decision and action to keep our system operating in an efficient and secure way. So we need real-time power system analysis, we need real-time simulation, of course, and we need real-time decision support. Don't forget that now the utilities, the large utilities, are not alone taking decisions. We need distributed decision making. And of course, we need data-driven methods. For that, we need historic data. We will use also real-time data and of course, machine learning, different methods for machine learning. And one important question is, what are the requirements to use these data-driven methods to support the players and markets activities? Sometimes we focus a lot on the methods, but we forget that they are to be used in practice. And if this application has to be successful, we have to look at the requirements for their use. So, in the frame of this legislation, namely for Directive 944, we need to give very concrete replies to this question. And maybe we can have two different questions that are also very important. We should ask ourselves how to use data-driven methods to contribute to the advancements, and how to use the results obtained with those data-driven methods to contribute to the advancements we want to ensure, or we must to ensure. To give replies to these problems, we have been working in different models, new methods, and to test all these models and methods, we felt the need to have a very good infrastructure for real-time simulation and management for power and energy systems. And we have been developing this Martin platform, which is based on multi-agent systems. I can divide this platform into 4 different levels. The first level in the bottom is the real-time simulation level. For that, we use our algorithms, but all we know the difficulties around the real-time simulation in power and energy. So we also use a professional platform for that, namely, in our case, 2 different systems from Opal RT. And then we have the real world, the physical world. And the next layer includes everything in this physical world we live in, namely all the buildings, all the equipment, and of course, all the gateways and all the communication means that we have. And the third level is the level for multi-agent systems. We found that multi-agent systems were the best approach to have our models and our algorithms, and we are using multi-agent based platforms. And finally, the top level is the level for the intelligent applications and services. This is the image for our living lab. In fact, I always say that you are invited to visit us, to discuss with us our solutions. But when I look at this photo, I must confess that it looks much better than in reality. So don't be disappointed when you come here. It's not maybe so nice as this picture, not so green, because this is maybe the greener part of ISAP campus. But in fact, this is a very good building for testing these solutions. Also, some pictures of equipment that we are using. Mostly we are using equipment bought from the shelf, equipment which is used in real buildings, in real industries that we can buy. Simply we are adapting this equipment to our needs. So we have a lot of work adapting the equipment, and also to make it for our use in the simulation, because we want to control our equipment using our software, and this usually is not possible when we buy from the shelf, off-the-shelf equipment. So the most important topic of our research is about artificial intelligence models for power and energy systems. And of course, there are a lot of models, a lot of applications of AI in power and energy these days, a lot of papers in the literature, some books also. But if we look at the old possibilities in the artificial intelligence world, we see that power and energy systems are taking benefits from only a small part of those possibilities. Namely, currently, we have quite a good number of optimization and computational intelligence applications and models. Also, machine learning is being widely used, as well as knowledge discovery. But when we look at user modeling, when we look at semantics, ontologies, ambient intelligence, expert systems, cyber-physical systems, context awareness, taking benefit of all these AI possibilities, I must say that power and energy systems are not taking the good advantage of all these concepts and models and methods. So we are working in some of these areas. For that, of course, we need funding, we need partnerships, because it's important, a multidisciplinary approach. And in Look for Replies, we have been involved in more than 60 projects in the past 5 years, different kinds of projects, mostly European funded projects, but also national projects and projects with partners outside the European area. And it's of course very important to have partnership with academic partners. It's the basic of our network, but also it's very important to have companies and the industry inside these projects, because like that we can deal with the actual problems of the industry, of the companies, and test our solutions for real world problems. So, coming back to Martin, Martin is about multi-agent simulation and multi-agent management of energy resources in real time. What we have inside is, of course, the consideration of the electricity market, all forms of electricity market. Also, we need to model the aggregator, the operator, physical resources, and have some simulated players, which we do not have at each time present in our building, for instance, in our experiment. And on the other side, we have all the other aspects, namely demand response, optimization, the contracts, the context, decision support, and so on. And what is really important is this part in the bottom of this slide. Because of course we must have learning if our systems are intelligent and if they are automated, if they are taking decisions by themselves, they must learn over time. Also, they must be contextual, because a decision that is very relevant and very intelligent in one context may be very bad in other contexts, because the context is very different. So this is very important, and we have learned this over years. We have always contextual approaches. And this TUI that I have here, this module, is also very important. This model refers to the management of efficiency and effectiveness, because efficiency and effectiveness are both very important, but when it comes to real-time operation, I must manage them in the best possible way, so that I provide the best possible solution considering the time constraints I'm facing. What we do is that we have a selection of alternatives, different algorithms that can address the same problem. And in fact, with this module, this management model, we can choose the best possible algorithm, the best possible approach in the frame of each context that we are facing. Another view of our platforms, in this case, what I must refer is that one single multi-agent system is not enough to address this very distributed problem, because this is a very complex problem, a very dynamic problem with highly distributed nature. So we need a set of multi-agent systems. And one problem we started having and feeling was the interaction of these systems among themselves. So we needed to study and to have new models for the interaction of multi-agent systems with the concept of a multi-agent system society. And going on with this concept, we should evolve. And in fact, we realized that the existing models for multi-agent systems are not the best one and do not suit our needs for this environment, this new environment in power and energy systems. We need dynamic agents, but also a dynamic approach for these agents to be part of the multi-agent system. So we are also working on this new approach and this new model for agent-based ecosystem framework for smart grid, supporting all these new concepts. For instance, when one player is inside one community and this community is part of an aggregator, they are using services, external services, and they want to be taking the best opportunity to fulfill their needs with those services. So it's very likely that they want to change the provider of one or other service, and maybe it's also likely that from time to time they want to change to a different aggregator or even to a different community. And we are working on the concepts and on the models, the energy models, but also the informatic models that give support to do all these dynamic changes in real time without losing efficiency or security of the system, of course. This is just an example for a problem where I have retailers, the traditional energy, electric energy retailers, and also I have aggregators. So I can model this with a set of agents. As you can see here, I have my retailers. In this case, the retailers are considered as clients of these services. Then I have my different players here. I have service agents from which the other players can take service, the external services I was mentioning before. And even I can have agents that are not in the frame of a multi-agent system. They can cooperate with one multi-agent system, with several multi-agent systems, but they are agents which are independent from the existing multi-agent systems. And all these models must be coherent, they must be driven by the goals of their owners, let's say, because each consumer, each community, each aggregator should be modeled according to their own goals and also to their own constraints, but they should be able to work together. So this is a problem in which the different players should, on one hand, fulfill their goals and compete with the other players, but on the other hand, they must somehow cooperate because in fact they are interrelated, and if they do not cooperate, the whole system will be broken, and at that time the lights will go off. Okay, one important aspect is about semantics. I guess that you have already heard about interoperability. Interoperability is currently considered as a very important topic in power and energy. And the reason for this is quite simple. Traditionally, we had a small set of large utilities in the system, and they ensured most of the needs we had. But right now, we have a set of large utilities still there, but also we have a large, very large set of small or medium-sized players that are also involved in this system, and they are involved not only as passive players but as active players. They are contributing to the operation of the system, meaning that they have maybe a positive contribution, and this is good, but maybe they have a negative contribution and they can harm the operation, the good operation of the system. So now that we have a large set of players, they are working with many different components, equipment, and systems. And all these pieces must work together. That's why interoperability is so important. But interoperability normally is understood at the level of physical interoperability or communication interoperability. And to put everything working together, in fact, we need to go further. And this is about semantics. The different components, the different systems, the different algorithms must somehow understand the concepts that the other systems, the other components, the other equipment are using. And that's why in the last 5 or 6 years, we are working on semantics for real-time operation. Previously, we have been working on semantics and ontologies for electricity markets, but not for real-time operation. Now we are working on it for real-time operation. You can see that we have here the physical world, let's say, in this case, several RTUs, and we have a semantic converter. We have, of course, a knowledge model, a knowledge base with our semantic model. Then we have an engine, just it is a different kind of engine, not a physical one, but it's a semantic engine, an inference engine that deals with all this knowledge. And finally, we can issue notifications. We can issue alarms, but also we can also have automated operation and control. And this is very important because this is making easier not only the operation of the systems, of the buildings, but also the development of the solutions. This is an aspect of our internal system, completely developed, in-house developed. So it is not a bought system, just the pieces have been bought by us. And we do a lot of different things with this system. This system accommodates different algorithms. We are very often changing the algorithms because we want to test them. But the system itself is able to undertake the real-time management of the building. Here I see roughly half of that building, and we have a nice system that is based on wall boards, but also can be based on the management then in our laptops, in our mobile phones, in our tablets, and so on. So it's quite flexible, and it is being daily used by the people working on this building. This is an aspect of one of the control pages. You can see that we call it click to control, C2C, and we can define preferences. Then we can act on the system, lights, air conditioning, doors, not only energy. So we also have the control over doors, some physical security topics, and also we have permissions, of course, and users only can access and act on the rooms and on the equipment when they have the right permission to do so. These are some examples of our development. Of course, we work with some hardware. We don't develop so much in terms of hardware, but we have developed in this case yet another smart plug. You know that there are a lot of smart plugs in the market these days, but our smart plug is a little bit different because it is intended to work with agents, with multi-agent systems, to be aware of the context and to be aware of other equipments in the same area. This is an aspect of the board in one of our walls. Also here it is a touch panel, and you can control almost everything depending on the permissions you have. For instance, here if I click, this is the control for the doors to make sure that the door will be open when I arrive at my room or the meeting room, for instance. I'd like also to say that, of course, we have some research opportunities at our labs, at our research center. So if you are interested, please contact me. And every year we recruit a lot of master and PhD students, and also people already having a PhD. Also, I would like to call your attention to the need that we have to have access to open data sets. This is important. I am involved in several working groups in IEEE. We have been taking this problem very seriously, making efforts. So please use our public data sets. I believe it's worth to use them, and also please feel free to contribute. It's very good if you can contribute with some additional open data sets that can be used by the community. This is important not only in academic but in professional terms. Also, we are taking organizing some worldwide competitions. So if you are interested, please take a look at our site. Right now we have an open deadline for the end of October, meaning that you can compete if you are interested, you can disseminate it to your colleagues. This competition in particular is related with solar generation forecasting with real data. We have also other competitions, namely in the computational intelligence domain with evolutionary computation. Right now we have no open competitions because they have just closed it, and the winners have been announced in the previous week. But we are going to have new editions because we run new editions each year. I will go on with this, just a brief reference to the need to consider real data, for instance, for energy tariffs, to study very attentively what happens with these tariffs. In this case, this is an implementation in our building, considering 5 different players. We consider that the building is owned by one of these players, and that this building has office rooms that are rented by other players, by companies, for instance, or by professionals. And we have some shared photovoltaic generation panels in the rooftop. So we made some experimentation, not only computational, but physical experimentation with the sharing of the generation of these panels. And very briefly, we used different kinds of auctions in this market. We used a physical implementation that I showed you before in a photo when I showed our equipment with single board computers. And in fact, this implementation really shows that for different scenarios, you can see here very different scenarios, we can in fact have significant advantage when taking these new opportunities for communities, for resource sharing, for peer-to-peer transactions, for local electricity markets. So these are the average prices, and they are compared with the difference between demand and supply. Of course, if the community is able to have higher supply, it will be more comfortable for this community to manage the energy resources, and the prices can in fact be impacted and can be lower than the prices provided by a traditional retailer. So I thank you very much for your attention, and of course I'm available for some discussion if you want to do so. Thank you.
Thank you very much, Professor Vale. I'm opening now Cloud for discussion. You can place your questions under question and answers, or you can put them in chat. We already have 2 questions. One is from Vladimir. He asked, could you please share your thoughts on how the notion of fairness in energy communities, or lack thereof, will impact their success? Where do you see fairness to be most important? Virtual net billing, energy sharing, entry-exit clauses of members, etc.
This is, in fact, a very, very relevant question. I had no time to address this topic, but this is a topic we are very much interested to, and we are working in this topic. Thank you for the question. Fairness is very important when we come to a distributed approach, because now the solution really impacts each of the players, and I can say when it comes to communities, each of the consumers. And the problem is that models that are traditionally used, for instance, optimization models, but also the new machine learning models, are not correctly dealing with optimization. And one of the problems I have been seeing in the past few years is that people, most of the times, are addressing communities, aggregators, all these kinds of distributed organizations with the same models they were using to address the centralized organizations, which are the traditional organizations in power and energy system. And this is not possible. So it's very important to ensure fairness. For instance, when it comes to a community, when consumers are invited to develop strategies to have their flexibility, their demand flexibility delivered to the whole community, or even delivered to the aggregator or to the distribution system operator, the fairness in gaining some benefit must be ensured. So optimization cannot be applied in the old way, I would say. For instance, there are different kinds of approach. You can have an historic approach, registering all the benefits that each player is having a long time, and then considering in the optimization this historic. Also, you can, inside the algorithms, put additional strategies to consider the fairness. And fairness comes together with some kind of reputation, because we must consider not only the fairness, but also the reputation of each individual or each community. So this is important inside the community. This is important among communities. This is important among aggregators and so on. So in fact, there are already some strategies for that. In summary, these 2 kinds of strategy outside the algorithms, with additional algorithms that rely on the historic registration of all the contributions and benefits, or inside the algorithms with changes in the algorithms themselves to consider this topic.
Thank you. The next question is coming from Shir Kilkish. Thank you for this valuable lecture. How should sustainable energy communities better interact with the broader energy system to increase demand flexibility and demand response options beyond the power sector? For example, the info kit for the European Mission on Climate Neutral Cities by 2030, with 112 cities selected, recently emphasizes cities have multiple opportunities for harnessing a wider range of renewable heat and cold source in the local context in an efficient and flexible way as a means of increasing renewable energy deployment and deepening the process of energy system integration. Can agents in Martin also have the opportunity of engaging in Power-to-X options with the heat sector?
Yes, this is another very, very important topic, because in fact, energy itself and electrical energy are not alone. We should take advantage of all possible interconnections, all possible uses between the different forms of energy, so heat, cold, and electrical energy. Although I must say that we are seeing the electrification of everything, almost everything, because you see now that even heating and cooling is coming more and more electric based. Vehicles, transportation, I'm not just talking about small vehicles, but about buses, for instance, they are coming to the electric field also. So we are assisting to the electrification of different sectors. Nevertheless, it's very important to consider the interaction of all those forms, all the existing forms of energy, and we should be taking advantage of that. Also, we should take advantage and consider energy and the other resources, namely water, for instance, the nexus between energy and water, the nexus between energy, water, and food, because food can also contribute to the sustainability or non-sustainability of communities, of cities, and also transportation, because transportation is not only about energy, electric or non-electric energy. Transportation is about organization, about the time we spend when traveling, and so on. So it's about the organization of the community and of the city. So my reply is definitely yes. It's very important to consider all these interrelations. It's very important that our models do not only consider a part of the problem. Martin is able to accommodate these models. In GECAD, we are mostly working on the electric energy part, because it's where we have the most know-how, but also we have some work about heating, and we have some work about physical security, and also about, as I mentioned, about mobility, so all kinds of transportation and mobility. But Martin does not only accommodate our models. In several projects, one of the best advantages of this infrastructure is that in several projects, Martin has served to accommodate the algorithms of our partners, because it is sufficiently open to work with remote data and remote algorithms. And in that frame, Martin has already worked with different approaches for managing heating and cooling resources together with the other resources.
Thank you. One of the ways that we think, I'm more from the energy planning side, so I see clearly that smart grids are coming. We will need a lot of them, but the question is how to move it forward, not technologically, but from the point of view of business model. You need to have some signal that would signal the users when to spend more electricity and when to spend less electricity. There are several approaches, but what I think it's a reasonable solution for Europe is to use the price as a signal. So we are already starting slowly to link wholesale price and retail price. And this could serve as a good signaling. But now we have a following situation in which wholesale prices are extremely high most of the day because the marginal electricity is coming from gas, and we have a crisis, and we see that there is a lot of pressure against the current marginal cost-based electricity markets, which would serve us well, but we also have to be very careful not to allow social problems by linking this electricity to homes. How do you see this coming out in a few years' time? Are we going to have a more reasonable price? Because what we need is actually a low price when there is a lot of electricity. So we use power for heating and charging electric cars at home, and a high price when there is not enough renewables. So we save on electricity. But how does it develop in the next 5 years, let's say?
Thank you. It's in fact a very complex, but also a very important matter. Thank you for the question. I must say that today we are not yet at a stage where all the players are comfortable in their roles. I must say that energy communities, and this was the topic for my talk today, I believe they are very important for the current and future needs when it comes to energy. But the interaction between the traditional players and the new players is not yet clear, of course. And all of them are looking for the opportunities. I must say that I see some very reputed and large utilities with a very intelligent approach to that. So they are looking at the advantage they can have, but accepting that in fact future is not like the past, and that if we want to fulfill the energy goals we have to make changes. So this is what I call an intelligent utility, because they are facing the changes. When it comes to the contribution of these distributed players, namely consumers, there are two approaches when it comes to electricity or even to other forms of energy, which is an implicit approach to demand response, changing prices. And of course, we have to deal with those social issues. We must take care about how to change prices, how it impacts people and industry and the economy and so on. But this is the implicit way of demand response. And then we have the explicit way of delivering the flexibility, the explicit demand response, dealing with demand response events that are declared, and people know that in a certain period it's good that they increase or decrease their consumption. And of course there are a lot of complex issues there, but one, I believe that it is very important to come up with good, efficient, but cheap solutions which are automated, because most people don't have the time during the day to pay attention to these calls, and sometimes these calls must be done with only a small anticipation. So we only have a small period to react. So it is very important to have automated intelligent solutions, and it is also very important to have simple solutions, simple business models. When we work with communities, and we had a demonstration project in Portugal, in 3 small cities, and we learned that sometimes we have to put apart our complex mathematical models and to come up with very simple models for demand response, models that people can really understand. If I contribute like this, I will benefit like that. So I believe that this work on business models, namely when it comes to small communities and to individual players and families, it's very important. It has to be done, and we have to find innovative approaches. For instance, in that case, we had an aggregator in the project, and we worked on a new kind of tariffs that were put in place when people contributed positively with demand response. So the community had benefits, and then the tariffs would benefit the particular consumers that had those contributions.
Thank you very much. And with this, I would like to thank you for your excellent lecture.
Thank you very much.
Thank you. Muito obrigado.
Obrigada.
Now we are moving forward. I would like to ask Professor Karen Mascarenhas to take over chairing the session and start with the panel. Karen, are you hearing us?
Ele não está vendo, agora ele vai colocar.
Hi, Nevin. Karen is asking a minute, please. She has connected the system.
Okay, let's have a 2 minutes break then.
Yes, thank you.
Start in 2 minutes.
Yeah, thank you.
Okay. Okay, she's
there.
here.
Karen, we didn't hear you.
Sorry, I'm here.
Okay.
Hello, are you hearing me?
Yes.
Okay, great. Thank you very much. So then let's go ahead. So I would like to welcome the participants, the panelists, the researchers, the academics, the industry, government, and society to this SDEWES conference in São Paulo. And first of all, I would like to thank the conference committee for opening the space in the conference for the discussion of the challenges of social perception and public engagement towards sustainability. My name is Karen Luis Mascarenhas. I'm the Deputy Coordinator of a project which is called Social Perception and Science Diplomacy on Technology Transitions towards a Low Carbon Society. This project, we take it ahead in the Research Center for Greenhouse Gas Innovation in the University of São Paulo, where we are here. Professor Sigmar is the coordinator of the project here together with me, and also Suani Coelho, who also works at the Research Center. We are all together here. Unfortunately, we can't have everybody over, but at least a small group of people are here. Okay, I'm also the Director for Human Resources at the Center, and I welcome everybody. So, well, first of all, I would like to, yeah, it does not work. Oh, sorry, my presentation doesn't go ahead. Just a minute. Oh, okay, thank you. Well, as this conference has been discussing, one of the main challenges of this century is to drastically reduce carbon emissions, limiting the global average temperature increase to up to 2 degrees Celsius, then reviewed to aim to 1.5 at most above the pre-industrial area. So other challenges also include the access to clean and fresh water, as well as energy conversion, enabling well-being, livelihoods, and at the same time preserving the environment, the nature, and the ecosystems. Well, Latin America is one of the regions that has been the most affected by climate change, visible by droughts, forest fires, and floods in some areas, deepening problems such as poverty and hunger, calling for climate justice for all. So, well, the Research Center for Greenhouse Gas Innovation, where we work, is focusing on developing solutions to reducing the greenhouse gas emissions and supporting Brazil to achieve the nationally determined contributions through research and innovation. The center is a result of a joint effort from the government, which is through FAPESP, which is the funding agency of the state of São Paulo, the industry through Shell, and academia by the University of São Paulo in a triple helix structure, which the three are working together in the effort to develop these solutions. So the center is working on solutions to reduce the greenhouse gas emissions. So with technological, economic, they are expected. So how do we achieve this development without harming the environment and the planet, you know? So that's exactly what we're working here. So focusing on solutions that are developing the technologies, developing economics, and developing environmental solutions, but also work development and preservation demands understanding people's values, behaviors, and in order to deal with their expectations, reactions through sounding communication. So here we have to include also society. So recently we started a year ago a project focusing exactly on that. Society has an important role to play, changing habits, assuming conscious consumption, recycling residues, and adopting clean energy and sustainable products. This will require the contribution from all. So recently, the Research Center has started a multidisciplinary project to integrate society in the research to work together. One of the first efforts of the project in social perception and science diplomacy on technology transitions towards a low-carbon society was to search in the literature. Oh, sorry. Oh, here. I'm sorry, it's very sensible here. Okay. Okay, so we worked here with a multidisciplinary group to understand the main factors that influence the social perception of different energy sources and technologies. So we identified 15 of these categories. You can name them like the risk perception, the benefit perception, the psychological factors, depending on the technology, also if the people accept or not, the previous and the actual experience they have with the different technologies, the knowledge they have about them, because these technologies are complex and lots of times not very easy for the people to understand, or even for them to have knowledge, awareness about them, for what they're doing, what is their aim objectives. Communication, the relation they have with these stakeholders, the economic aspects, the policies that are in place or not, the environmental aspects, the social demographics, that depends on the area these people live, depends on the kind of knowledge they have, depends among the level of education. Also the cultural aspects, the decision-making process, and also ethics. So when we talk about the social perception here, we mean the society as a whole. So it includes government, industry, academia, the NGOs, the media, the investors, mainly all people. So when we talk about these perceptions and understanding how people receive and perceive these different technologies and how they cope with adapting to climate change, are aiming as what we aim to discuss. So the objective of this panel is to discuss the social challenges in the Latin America scenario, focusing on the latest research on social perception, engagement, technology acceptance, and sustainable behaviors, providing new perspectives for all stakeholders. So here together we have a multidisciplinary team of specialists from different backgrounds and expertise that will present their views on the major social challenges in climate mitigation and adaptation, clean energy availability, and their effects on employment and income opportunities. In addition, they will provide a reflection on people's behaviors and engagement towards different technologies and solutions in energy, water, and integrated systems. So to begin, I would like to introduce then our panel on the challenges of social perception and public engagement towards sustainability. And our first speaker, which is Dr. Rocio Diaz Alvis. She's a senior researcher fellow at the Center of Environmental Policy of Imperial College London since 2004. She acted as a deputy director and energy and climate change program leader for the Stockholm Environmental Institute Africa Center in Kenya from October 2017 to March 2022. She has extensive work and academic experience in sustainable assessment and environmental management tools and methodologies. Her research area focuses on sustainability, assessment, and deployment of bioeconomy, land use and natural resources, and the synergies with energy sustainability and other SDGs. Her research interests are in sustainability assessment, economic, environmental, social, and political institutional, with applications to renewable energy and climate change impacts. Let's welcome Dr. Rocio. Thank you.
Thank you very much for the introduction, Karen, and for the invitation to this panel. And I think it is a very important topic. And let me just share my screen with you. And could you just please confirm you can actually see it?
Yes, but you can put it, yeah, perfect.
Okay, thank you very much. So I think the presentation is going to be on an overview of these challenges and opportunities for inclusive sustainable pathways for bioenergy and bioeconomy in Latin America. But these pathways are related to social perception, social acceptance, and public engagement. And I think what I'm going to do is just to give you a brief overview of this and some of the methods that I have been using for different projects. So as you mentioned in the introduction, I mean, the main phase that we are, the main impacts that we are facing related to climate change are, we can see them in these climate change hotspots and the impacts they have in Latin America. So you can see all the areas that are close to the coastlines are severely impacted, of course, inland areas as well. And I think from this work that is not mine, it's from Montenegro and you can see what they presented as the current observed impacts and what they are expected in 2100. And if you have been following the news in Europe, you have seen the problems we have now with these impacts on climate change. So they go from these increasing temperatures to higher frequency of extreme rainfalls to decreasing rainfalls, and also the higher frequency of the storms and hurricanes. And you can see that literally all Latin America is going to be affected, or it's expected to be affected by that time. And if we see also the cumulative CO2 emissions in the region, you can also see that many of the countries in Latin America have at least had until 2020 the emissions similar to the most industrialized countries, also in Europe and other areas in Asia. And we cannot forget about the impacts that COVID-19 has had. So if you see here, the difference between South America, North America, and Europe, it's really significant in terms of the deaths per million. For the cases of Africa and Asia, it is still undoubted the number of the data, if it was collected in the same way as in other regions, to really determine that. But what it is important here is to see what it has the impact in terms of the depth of recession. And you can see Latin America also, how badly was it affected between 2020 and 21. And although it is starting to go into some kind of recovery, we know that there are still many things that we have to do. So moving into the access to electricity, that is an area that Latin America in general has managed to improve consistently since the 1990s up until 2020s. But we still know that there are still a number of people, quite a large number in rural areas that have not access to electricity. But so within the renewables energies, we have bioenergy, and you can see here the domestic supply of biomass that it was up until 2018 for the Americas. And you can see that the liquid biofuels were significant, and this was mostly from certain countries in Latin America, but it's significant compared to the rest of the other global areas. And liquid biofuels are the ones that still have quite significant. But solid biofuels are still used, particularly in rural areas, and this is mostly for cooking. So here it's where we can discuss what is bioeconomy. And bioeconomy is really a move from these kind of low productivity natural economies to these high input fossil economies, but with all the implications of them on climate change, to this bioeconomy, where we use these biological resources into value-added products such as food, feed, and bio-based products, including bioenergy. And the relationship that bioeconomy has with the SDGs is really how we can create this value from the natural resources to have implications, positive implications, as we are trying to do with society and with economy, and how we can link them also to circular economy. So these emerging opportunities look at food security, health and well-being, bio-based industrial development, and this aspect of sustainable energy, which includes also not just liquid biofuels, but solid biofuels, biogas, and of course, all of them can be related to other types of renewable energy. So most of the research that I have been doing has focused on the methodologies to assess the sustainability assessment of these different forms. And one of them is, of course, through the use of indicators and sustainability assessment. So we have been using this framework for a number of years, where we can have 4 pillars of sustainability rather than 3. We can use socioeconomic, but also policy and institutions. And this is also governance. So much of this social acceptance, perception, and engagement comes into this governance system. But we still need data and indicators, and that is also why this is a novel area. So we can talk, for example, about social actors and the acceptance and bioeconomy. So how the wider society knows or is still largely ignorant of what it is, what does it mean, and what it does, and how these different social actors may be understanding this, but in different ways. So as Wegner and Kelly indicated, the best technology does no good unless people use it. But how different social groups understand, for example, bioeconomy or energy or bioenergy, as we heard also with the presentation before. So social perception and acceptance are considered as embedded in society, on how these are adopted technologies and applications, how there is an increasingly acknowledged as essential for their successful development and market diffusion, or the impacts on the development of bioeconomy projects, all their infrastructure and chains. And the biofuels, which is a sector within the bioeconomy, and it is probably the one that has been more widely documented. So all of them take different forms and involve a different range of actors. This social acceptance, for example, can be influenced by several factors. They go from awareness, knowledge, opinions, attitudes, and behavior to the perceptions of risks and benefits, or the perceptions of the wider societal and policy dimensions and other sustainability issues. So we have been applying several of these indicators through a range of different projects and worldwide, but you can see that in Latin America, we have applied several of them. And in the case of Latin America, we have gone even from the use of different type of biomass that includes bamboo, that also has global distribution, same as sugar cane. But you can see that Latin America, and undoubtedly Brazil, is one of the main users, along with Colombia. But also other areas that have been emerging, for example, waste uses and the potential of waste for other aspects within bioeconomy. This is the case of Mexico, where it has been improving through the use of circular economy. Or waste use also for electrical power in Brazil, as the case of how much biogas has improved also in Brazil through these different bioeconomy uses. In addition, pellets production or other feedstocks, such as the case of palm oil, both Brazil, Colombia, and even Mexico. So with all these resources and how they can be utilized, we have considered also landscape governance. And why for bioeconomy and bioenergy? Because this is a way where you can not just engage, but co-develop with the social actors. So it is a must from sustainability point of view, and in landscape governance, the inclusion of all stakeholders. So that means that you can have a common resource where all the local and national stakeholders are involved somehow with the value chain, through the use of the final products, and how they can also be engaged. So it is a better way to really bring together the resources with them. But you have still to consider the trade-offs and synergies of bioeconomy and bioenergy. So from the environmental aspects to the local community and all the socioeconomic issues. So these trade-offs and synergies are the most important. So what are these challenges for the bioeconomy and social acceptance? Well, we still need to consider context, regionalization, and localization. And there is still no guarantee that these benefits, let's say, of bioeconomy will be equally beneficial to all groups in society. And it may, in fact, it may reinforce or even deepen existing gender and social inequalities. So gender is also another important aspect of this social acceptance. Views from women and men are different. And even if they are equally interested in this type of sustainable production, they may have different access to resources, knowledge, labor. So we have to see how we can really engage into this type of technocratic approaches, and to see how they may affect socioeconomic, cultural, and gender impacts. And all this is going to be done through these studies on social perceptions. So we have to keep in mind these just transitions. So just to finalize, how we can bring together all these issues on social acceptance is really through a strategic view. We have to try to link all these different type of policy agendas and all the views of all the different stakeholders and all the implications and the positive aspects from all these 4 pillars on sustainability. So I will leave it here because we have the whole panel to discuss. Thank you very much. I think you are muted, Karen.
Thank you, Rocio. Thank you. That's a very interesting presentation. That was wonderful. Thank you very much for sharing your thoughts. We have 5 panelists, so I would like to move forward to the next panelist, which is Suene Coelho. She has a master's degree and PhD in energy by the University of São Paulo. She is currently a lecturer and a thesis advisor in the graduate program of energy at USP and the graduate program of bioenergy, USP Unicamp UNESCO, as well as coordinator of the research group by Bioenergy, the GBU, at the Institute of Energy and Environmental at USP. She's the former Deputy State Secretary of Environment of São Paulo State from 2002 to 2006, and member of the United Nations Secretary General Advisor Group on Energy and Climate Change. Well, she develops research on renewable energy, mainly on bioenergy and environmental and social sustainability. I would like to welcome Dr. Suene Coelho, please.
Thank you very much. Thank you for the invitation. In fact, when Karen invited me to come for this roundtable, I was a little bit worried because I am just an engineer and I have not so much experience with public perception and so on. But I think that I could share with colleagues some experience in the areas of energy sector, energy transition, and tell a little bit about how is this behavior. So I would focus on 2 main issues, the alcohol program, and then our energy efficiency program that we have for household appliances. Well, the alcohol program, as you know, started in the 70s. And it started just blending ethanol to gasoline. And later on, at the end of the 70s, the government introduced the alcohol cars. And there was a strong campaign for society to go for alcohol car. I remember there were advertising saying, alcohol car, you are going to have one. And in fact, people went for it. And most new cars were alcohol, and there were the alcohol available in the pump station. There is a law saying that every pump station in the country must have an ethanol pump. And it ran more or less smoothly until the 90s, when we had a crisis and a shortage of ethanol supply. Sugar prices in the international market, they were better. Producers decided to go for sugar instead of ethanol. And there was a lack of supply of ethanol. Long lines in the pump stations waiting for ethanol because the cars could run only with ethanol. So that has a consequence, a strong lack of confidence of the society. And of course, people moved for gasoline. And alcohol cars started to decrease, and the alcohol car production stopped. And this more or less remained the same situation until 2003, when the flexi cars were introduced. And flexi cars, as you know, are vehicles that can run both with ethanol and gasoline, with any blend, since pure ethanol to gasoline. And despite the previous negative experience with ethanol, people went for the flex car. People understood how important it was, and in fact, the choice, the decision was in the hands of the consumers, and then they understood that they went for it. So nowadays, more than 80–90% of new cars are flex cars, and consumers know well how to make the decision, comparing ethanol prices to gasoline prices. If it's up to 70%, they go to ethanol, otherwise they go for gasoline. So it worked quite well. On the other hand, so the conclusion that it can take in this area of fuels is that society understands well, and the public perception is very based on economics. If you ask people if they go for biofuel because of climate change and reducing carbon emissions, probably even if they go, probably it's most influenced by economics and by price. On the other hand, it's still talking about with the COVID pandemic, we had a strong decrease on demand because people could not go out, people started to stay at home, and so the demand for ethanol decreased. So the offer of ethanol also decreased because the ethanol suppliers could not have enough possibility to stock it. And then they reduced the ethanol production. It was an important impact in the ethanol sector. But what happened was that, we have the Renova, which is the market for carbon credits sold by ethanol suppliers to gasoline distributors. And by that time, distributors pushed for a reduction on the carbon targets, and they were reduced for half. It was a dramatic reduction on carbon credit with a dramatic impact on the ethanol sector. And even more recently, this year, based on the discussion of reducing fuel prices, distributors again pushed for reduction. And what happened this year, just it was issued a decree about that, there was a postponement of the targets of Renova of the carbon credits from this year to next year. So what we can see is that from one hand, society understands the importance of ethanol and biofuels and go for it when it's available and when it is economically competitive. Other stakeholders in society have a different perspective, and they do not see the importance of biofuels for climate change. So we have this kind of duality in Brazilian society. The second case I'd like to share with you is regarding energy efficiency. A little bit differently from ethanol, society has a different perception on energy efficiency, mainly in house appliances. We have strong policies in Brazil obliging all manufacturers of household appliances like refrigerators and so on, ovens and so on, to have standards and limits for energy consumption. And it's mandatory that any of these appliances has shown when you're going to buy a new one. However, what we realize is that people do not care so much about it. people go more for the type of refrigerator, the color of the refrigerators, and not the energy consumption of the refrigerators. So I think it depends on if society has adequate information. In the case of biofuels, there is always campaigns and public is very much informed about it. In this case of the energy efficiency pattern, there was not enough information for the public, so public does not know about it. And this is probably true because in the recent past, when we had to change lamps from conventional lamps for more efficient lamps, and there was a national campaign for it, then people went for it. It's important to note the participation of women, because women taking care of households, and the women decided they wanted more efficient lamps because then the electric bill would be lower. So it was an important participation of women in this sector. Well, considering these two study cases that I briefly discussed with you, maybe it's for the psychologists to discuss why different behaviors from society. I just give it back to the psychologists in the round table. But I think that when people have a good campaign and they receive the adequate information, easy information, didactic information, adequate for the public in general, they understand it and they go for it. But it's necessary to really to do some capacity building with the society so they can understand why it's important or not and how to deal with it. But I think I can stop here and you can discuss it later with some questions. Thank you, Karen.
Thank you very much, Soni. Wonderful. Yeah, very practical examples of things that we lived over here and that did happen all the places in the world, you know. So they're simple examples of how these kinds of things affect people. Well, now I would like to invite Dr. Kathleen Araújo to talk. She is the director of the CAES Energy Policy Institute, and she's an associate professor at the Sustainable Energy Systems, Innovation and Policy at Boise State University. She is specialized in strategic decision-making and planning associated with energy system change. This includes work related to targeted adaptations, such as decarbonization of regional industrial restructuring, as well as unplanned shifts, including extreme weathers and cyber disruption. She also is she's very into the writing books. She's got 2 wonderful books of energy transition, and I think that what she's going to share with us is very interesting. She's going to talk about the critical ideas and lessons learned for sustainability and energy transitions. Welcome, Dr. Kathy.
Thank you, Karen. Can you hear me?
Yes, perfect.
Great. Okay, thank you. So I want to thank you, especially Karen, for your leadership in bringing this really talented panel of experts together on such an important topic. I'm delighted to join everybody today, and I'm really looking forward to our conversation as we go forward. I'll be sharing the screen now. Can you see it?
Yes.
Great.
It's not in presentation mode yet,
yes,
but we can see it.
I'm waiting for it to jump there. Let's see. There we go. Okay, perfect. Okay, so in line with the broader conversation of this panel, I'll be talking through a number of concepts and lessons for sustainability. I'll be drawing upon broader theory and practice in science, technology, policy, and energy transitions, and look forward to how we can progress with this conversation. So I'm going to start with a very basic concept. I'm not sure if all of you've heard of it before, but it really stood out in my mind as I was thinking about this conversation today. And it's called the streetlight effect. So there's this old story about a man who lost his car keys at night, and he went back and was looking around on the road to find those car keys. He was looking underneath the streetlight to find them, and a police officer came by to help him. They looked up and down, they could not find the keys. And finally, the police officer said to the man, are you sure they're here? Why are we looking here? And the man said, well, that's where the light is. And in terms of the broader takeaway of this, it is to look beyond the obvious or the easy answers, and to keep in mind that we may need to innovate to advance with our solutions to the current problems we're discussing. So that brings us to this idea of lock-in and path dependence. Path dependence in particular was popularized by Paul David's writing. And it's this idea that prior choices can limit later ones, essentially through a crowding out effect. So even if there are more superior options that appear later, for instance, advanced renewables in terms of decarbonization, lock-in can block adoption. And so what contributes to lock-in? It can be driven by sunk costs or the need for new learning. It can be also inhibited by increased returns. So meaning the more you use those older, less efficient or less effective options, the more value you're getting from your original investment. Lock-in can also occur because of vested interests. So we have a personal stake for whatever reason in a given pathway. Now, I'll give you two quick, simple examples. One is the keyboard that we all use on our computer, and another is suburban systems, which is a little more complex. Now, with keyboards, many of you may know, and the keyboards vary a little bit across countries, but generally they're not set up to follow the letters of the alphabet. And you may ask yourself, why? That's originally driven by a choice made back in the 1800s and continued through to the current day. And that's because the old printing machines and typewriters would jam up when certain letters were used in sequence. So the letters were redistributed on the keyboard to avoid the jamming of the technology. And yet today, even though we're no longer using those old typewriters, we've continued forward with a keyboard. And so there are more perhaps superior options with keyboards today, but we're continuing with the older version. Now, to take that to the idea of suburban systems, roads, infrastructures, and communities could be built to favor vehicle ownership. So we're investing in how our infrastructure is laid out, how our cities are put together. Those are reflects prior decisions, yet they can create a car-reliant system that we continue to perpetuate because of those earlier investments and choices. So that brings us to the idea of carbon lock-in, which takes this one step further. And you may know Greg Unruh has written a lot on this topic. Now, it's a special case of path dependence. And from the picture, you see this gentleman wrestling with quicksand. And so it's hard for him to move quickly because he's stuck because of his previous choices to enter into the quicksand. Now, specific to carbon lock-in, the idea indicates that industrial economies have become locked into fossil fuel-based systems with related developments in technologies and institutions. So a vicious cycle is created where diffusion of more advanced technologies or pathways are excluded out of the discussion or the opportunities frontier, just simply because people are working off of what they've done so far. This creates this self-reinforcing reliance on incumbent options that are not necessarily permanent, but they do create this persistent market and policy failure or system barriers, which blocks out people thinking about other pathways. But there is good news. Peter Carnot and Raghu Garud, who have written a lot about path creation, highlight for us that we are not without choice. in an evolution, a historical evolution, where whatever you choose for previous technologies predefines what you're going to have going forward. There are alternatives, and there are opportunities throughout our evolution that can alter the status quo with what they call mindful deviation. So this acknowledges that there are open windows of opportunity for choice and new forms of human agency every day in a countless number of choices that we each make. And we need to account for this. In the terms of the broader theme of this panel, we need to account for path creation, not only in our framing and our thinking, but in our planning, our budgeting, and our governance. So remember this idea of looking for new points of entry. That brings us to another set of concepts, the early and the late adopters. So early adopters have an advantage where they have essentially the first choice of a new path. They may be able to set the standard, and they have the potential to become an early leader. So these are all gains for those early adopters. Now, late adopters also have advantages. They can sidestep issues associated with early use by advancing to the next type of technology or practice. They're not encumbered by infrastructure and sunk investments that usually follows the first movers. The late adopters can also benefit from the prior learning to move directly to the newer and more superior technology. Now, this difference was written about by Jose Goldenberg, who many in this forum may know, not only for his work with USP, but for his pioneering work within the field of sustainability. So he talked about the notion of leapfrogging, specifically technology leapfrogging for developing countries. And if we step back and we think about sustainability and superior moves towards decarbonization, he indicates that developing countries have their own set of advantages where they can avoid those lesser quality, inferior strategies that were adopted by developed countries, particularly with fossil fuel-based consumption. And these developing countries have this fantastic and valuable opportunity to innovate and share lessons more globally going forward. So if you take that concept one step further, we can talk about the S-curve. Now, you may know of this idea from Everett Rogers, who wrote about the diffusion of innovation in 1962, and there have been 5 iterations of that book. I recommend that for all graduate students who have any interest in sustainability or technology change. Now, the idea was essentially that Rogers put forward was about adoption patterns with corn farmers. So you can imagine farmers living near each other and seeing different changes in their harvest from one year to the next. And if your neighboring farmer has a better harvest than you, it behooves you to ask why and what you could do differently. And so the farmers were adopting changes in seed usage and other farming practices by learning from each other. Now, if you take this idea further with the S-curve, and you look at the right-hand side here with the top picture, the first S here is the slow adoption at the beginning, as there's learning and people are watching each other to see what works and doesn't work. And there may be barriers from old options. And then as you progress up the S-curve, there's rapid learning as more and more people see the benefits and they want to get involved. And then when you taper off at the top of the S, that's because the market is saturated, just about everybody has done it, and there's less opportunity to continue growing within that specific S. So it describes how new technology or practices progress across or spread across a market. Now, I want to draw your attention to these 2 graphs because you can see you could have one S flow then into another one that takes the overall group even higher to a more superior domain. Or you could think about it with the lower graph where you have S's side by side. So you progress up through one and then you substitute and jump into an entirely different pathway. Both are options to consider in this conversation. So if we take that thought one step further, Everett Rogers looked at it and said, let's consider the S-curve with types of adopters. So you have the early adopters from innovation to early adopters and the early majority, all the way to the laggards. And the key here is to understand the differences between these groups. And I think it speaks really importantly to the perception and the engagement themes of this panel. These different groups have different saturation for learning. There's the all-important role of the communication channels and opinion leaders, but most importantly, the differences between these groups can tie to their comfort level with risk and what they look to. So we'll keep that in mind as we keep going with the ideas. The last key takeaway from Everett Rogers' work, and you can tell that I like him, is factors that affect diffusion. So he spent some time and really unpacked what were some of the critical ways that enabled change that matter, I would argue, for perception and acceptance. So he indicated that there's the audience or the people in a specific population can see an advantage of the change by looking at what others are doing. There's the compatibility or coherence of the change with the community or population's needs and understanding. The complexity of the change can certainly affect the diffusion rate, the opportunities for testing, the opportunity or to observe or to understand clearly the positive results. And so all of these factors are good to remember, as well as how the adopters differ and how diffusion occurs as we continue this conversation around perception and acceptance. So that leads us to what I believe is our last concept before we talk about some energy transition cases. And this is the concept of unarticulated identities. And it's put forward by Josh Brinkman and Richard Hirsch. And it's a very fascinating topic that intersects not only with today's topic, but other areas such as marketing and politics. But we're going to speak specifically about sustainability. So this idea refers to an underlying logic that may drive or define an individual's actions in certain areas, but may not be apparent in broader group trends, for example, in voting patterns. And when Josh and Richard were looking at this, they were examining farmers in a conservative area of the United States, where the voting patterns were strongly in favor of the conservative president. But contrary to the president's very strong pro-fossil fuel position, the farmers were adopting considerable amounts of renewable energy. And how do you explain that disconnect? And that's this idea of unarticulated identities. And specific to perception and acceptance, it highlights a key area that we should consider as we talk about change and ways to levers to advance that change. So I'm advancing my slide and it's stuck here. Let's see. Oh, goodness. I may need to take it off. I'm going to stop sharing for a second and advance it. There we go. Sharing it again. Okay, back up. Oh, goodness. So that brings us to
technology is always challenging us too.
It is, yes, absolutely. Even when we talk about technology change. Thanks, Karen. So then turning to some interesting lessons from energy transitions. This highlights just a number of cases that I've looked at from different parts of the world, and we're going to talk about two of them in particular. But I want you to understand how some of the commonality that affected them. And this chart is probably familiar to many of you. It highlights disruption in the context of historical oil prices. And so the area in particular that affected these cases was originally the OPEC oil embargo, followed by the Iranian Revolution. Later, we had the global recession around 2008, 2009, 2010. More recently, we've had the pandemic with the global downturn. And this line chart hasn't been updated yet, but clearly the Russian war on the Ukraine is impacting all of us in terms of oil prices and other areas. Now, taking us to the transitions, I want to just give you a quick sense of how the energy transitions looked in sort of simple terms for how the shifts occurred. And we're going to be talking about the bottom two. So the Brazilian case of biofuels, and it's a real pleasure to be on a panel with two others who have already talked about that, Rocio and Suani, and I'll be taking it complementary in a different direction. I'll also draw some examples from Denmark with their wind adoption. So speaking to the Brazilian biofuels transition, so as we've heard already, there was pretty substantial shift, and Suani, you did a wonderful job of describing not only in research, but in personal terms of how some elements of that occurred. So I'm going to just draw your attention to the graph on the right, that with the line chart showing the first transition was biofuels adoption between roughly the mid 70s and the late 1980s, and you can see a pretty substantial shift. It's followed by a later transition, which Suani also pointed out, that had to do with change with flex fuel technology. So the shift, and we'll talk principally about the first one from 1976 to 1988. The auto fuel mix shifted from 1% to 51% with ethanol and biodiesel. Now, in terms how to explain that, so there was certainly repurposing happening across industry, infrastructure, and driver practices. In the agricultural sector, there were new practices for how to farm that increased yields. And you can see from the bottom center chart how the sugarcane yield improved pretty dramatically. And this is only up to 2010 there. The numbers continue to improve. There were also changes with sugar mills. They identified three markets that they could be targeting: the traditional sugar market, the ethanol market, and eventually the electricity market. And they found very clever ways to adapt the output depending on what was the optimal circumstance in a given time. Suani had also talked about the adaptations with automobiles. So the early ones were retrofitted to run strictly on particularly ethanol. Later ones were manufactured so that they could adapt with the flex fuel technology, so that the driver didn't have to worry about the conversion, and they could make their choice at the fuel station depending on prices. So that clearly translated then over to fueling practices. Now, some key takeaways from this case were historical familiarity, which is sometimes forgotten when we talk about perception and engagement. So Brazil had an early hub of science that had looked at biofuels and had been producing biofuels for automobiles as far back as the early 1900s. Brazil also had champions like José Goldenberg, who we talked about a few minutes ago in terms of leapfrogging. So as a scientist in the 1970s and continuing to the present, but particularly in the 1970s, when the urgent need to diversify was taking place, he was publishing with colleagues like José Roberto Moreira about the technical viability and the common sense of Brazilians pivoting to biofuels. You have other champions in the sugar industry and later automotive industry behind the scenes also actively mobilizing to enable the change. And perhaps importantly, the government role. In the 1970s and 80s, it was the key player defining the strategy for the country, but industry was a critical leader in the later days, particularly with the flex fuel technology, when the government was focusing on other priorities. So that brings us to Danish wind, which is another example of rapid and substantial energy system change. So you can, if we start with the lower right corner, you look at the electricity, in the period from roughly 2009 to 2021, which is really this portion, the mix shifted from 19% to 49%, but you can see that the longer term slope was even more dramatic. And in the top right, you see two maps of Denmark. While they're small, hopefully you can see that on the left, which was around 1980, the little black dots represent centralized power plants. So there were very few, but they were prominent in providing electricity for Denmark. And on the right, with the multitude of black dots distributed throughout the country, you can see how wind technology has been adopted by many prosumers who are providing the energy supply and consuming it in a manner that contributed to the country essentially now providing half of its electricity mix from wind. And how did that happen? Well, back to the idea of repurposing. People's skills were adapted and materials from shipbuilding, which was a very traditional craft and trade within Denmark. Another important adaptation in practice was applying cooperative ownership to wind farms. So historically, Danish farms or farm communities had shared equipment in order to simplify their investments. And they applied that idea going forward to wind farms so that when they looked out their windows, they could feel a sense of ownership and benefit from the wind turbines that were running nearby. They also adapted agricultural manufacturing equipment to produce the wind turbines. Now, like Brazil, there was historical familiarity, and I bring this point up again because I think it's an important one that's often missed in conversations about perception and engagement. People could think back to stories that their grandparents had told them about and to pictures they had seen with older versions of windmills being used to produce grain or to direct water flows. There had also been an early scientific hub in Denmark. It was very critical in producing wind-powered electricity in the late 1800s and early 1900s. Like Brazil, there were champions in the form of trusted scientists. In Denmark, it was Niels Meyer. When the government came out with a plan to adapt to the shock of oil prices, the government was putting forward the idea of nuclear energy. But Niels Meyer, as a scientist, rallied and produced a scientifically based alternative energy plan, which he published with other scientists continually to counter what the government was saying. And through his leadership, he showed the Danish communities how they would have alternate choices, which they ultimately adopted. So other champions in that time were the national labs, home inventors who were inspired by Niels and others, and as well as the wind users themselves and members of industry. Like Brazil, there was the government was a strong supporter at different points in the history, but it wasn't always. We know that government administrations change with their priorities, but like Brazil, the technology change continued and is enabling Denmark to be a wind technology leader today. So to wind things down, how do we think about societal acceptance and perception? Some key takeaways would be unplanned disruption, whether it was the oil shock of the 1970s or today with the Russian invasion of Ukraine. While there are certainly negative aspects to the conditions, they also present opportunities for change and improvement. We should consider mindsets and when we think about the topic in terms of early versus late adopters and how they're sort of programmed or hardwired differently. We should think about repurposing with natural strengths, recognize historical familiarity, and also consider local knowledge. And local knowledge, I'll call out in particular, is not only important for co-production and value-enriched information, but is a way and a process that can engage broader groups in the process and ideally arrive at a better solution that's locally important. Government doesn't need to be the leader all the time. Champions are very critical and especially with scientists can be trusted advisors. And lastly, we should recognize incremental learning in our framing. I'll leave you with a thought. We can't solve problems by using the same kind of thinking we used when we created them. Thank you.
Thank you, Kathy. Fantastic. Very, very good thoughts here for us to think about. Let's move on then, because we still have two other speakers. I will invite Fatima Bernado. She is the Assistant Professor of Social and Environmental Psychology at the Psychology Department of the University of Évora, Portugal. She is the researcher of the Center of Innovation in Territory, Urbanism and Architecture University of the University of Lisbon. And her main research is grounded on research, risk perception and climate change, and place identity and intergroup relationship. So I invite her to share her thoughts with us. Thank you very much.
Thank you, Karen. I will try to share. I don't know what's happened. Sorry. I don't know what's happened now. Sorry for my. You see my slide?
Now we can see it. It's just not in presentation mode. We can see it.
Okay.
Perfect.
Okay. Thank you, Karen. Thank you for the invitation. Today, I'd like to talk about people, and especially how people think and how people act. As we know, it's very difficult to change behavior because we have a lot of habits, automatic behavior, and usually change is associated with some situations to high cost and inconvenience. So it's difficult. So today I would like to talk a little bit about the barriers to behavior change and also how to drive people to change behavior or the strategies to promote more sustainable behavior. So we can identify a set of barriers to pro-environmental behavior. Usually we talk a lot about pro-environmental attitudes and how it is important to change environmental attitudes. But what we know in Europe and a little bit around all the world, now the people have pro-environmental attitudes, but they are not connected with real pro-environmental behaviors. And the question is the behavior, the question is not necessarily only the attitudes. So people think that it's important to protect the environment, but they don't do usually nothing to solve the problem. Another aspect is psychological distance and verbs. So one thing is think about that. Another thing completely different is act with the correct behaviors to environment. Another important aspect is the psychological distance. Karen already talked a little bit about that. As we know, when we talk, for example, about climate change, this is a very abstract concept, and sometimes the people don't feel connected with this. Usually when we ask people about climate change, people gave us examples of very distant things that don't have impact in their lives, or they talk about other people, other groups, other countries, other continents. So something that is far from their reality. Jane Goodall talked about think globally and act locally, but it's very difficult. This connection for the ordinary people is very difficult because sometimes the people don't understand very well the importance of their behavior. Another aspect that is important is the perception of reduced impact of individual behaviors. Sometimes the people think that have a perception that their behavior has low impact, is not enough important, and that others do not behave in a pro-environmental manner, and perception have a high personal costs and inconvenience. So they don't feel motivated to have this kind of behaviors that are difficult sometimes, and perhaps they don't have the perception of the impact of their behavior. Another aspect is the technology as a solution. Of course, technology it's very important, but sometimes people feel that it's the technology can solve all the problems. Or people have some individual behaviors like electric cars, but for him it's enough. So reduce the perception of individual responsibility, or in some situations they think that we don't need to change behavior because technology solves all the problems. And they are more focused in the positive impacts of the technology.
Não.
Sorry?
Porque se ela estiver falando...
Só que eu não consigo nem ouvir. Hã?
Sorry?
You may continue, please.
Oh, thank you. And sometimes they focus more or only on the positive impacts of technology and not in the negative ones. So the question is how we define or identify strategies to promote sustainability behavior. Of course, there are lots of aspects, but today I talk about these three aspects: change knowledge and more than knowledge, change motivations, change context, and provide tailored approaches. So the most common is to try to change knowledge, but sometimes it's only give the people information about the importance of their behavior or things like that. So they act only at cognitive level, and we need to think in environmental literacy not only in cognitive terms, but also include behavior and affective aspects. And in terms of behavior, sometimes it's necessary to improve the knowledge of people about how act in an effective way to solve some environmental problems. And another aspect that is very important is the affective one. In several studies identify that people change more the behavior for affective reasons, like environmental concern or risk perception, or an identity to the nature, identity to the environment, than for the cognitive aspects. Or in some situations, these two aspects are important to improve the change in the behavior. But more than change knowledge, sometimes it's important to change motivations. And it is important to identify what drives people. Of course, personal values are important, but more than the personal values, the importance of group and the perception about what group think, in this case about environment or this question. So we know that individual environmental identity is important and is strongly associated with climate actions, but there are some aspects that inhibit the pro-environmental behaviors. For example, many climate actions are associated with high personal costs and inconvenience. People sometimes may not consistently act on their values, and sometimes because do not always consider the positive impacts of their actions, and they often underestimate how much others care about altruistics and biospheric values and climate change. So it's not enough to have individual environmental identity to have the correct or the more pro-environmental behaviors. We need to add more things. And one aspect that is very important is group influence. The group influence proves to be a powerful motivator to change behavior, because being part of the group, being engaged is an important aspect, and in some situations, group goals become individual goals. What we see in this graphic as there are a strong relationship between group biospheric values and pro-environmental behavior. And this relationship can also be mediated by the environmental group identity. So the group are important elements that influence the behavior of the people. Another aspect is the social identity. People strongly identified with the group, and when they do not endorse biospheric values themselves, emphasize the group values motivate pro-environmental behaviors. So it matters what others do or we think others do. And in some situations, this is important to change the behavior. In this graphic, we have red lines and blue lines, and the blue lines is high values of identification. And the people that have high values of identification have a relationship between perceived biospheric group values and energy-saving behaviors, willingness to save energy for environment and other aspects. So, and this is very interesting because it's the impact of group is stronger in the individuals that don't have biospheric values. So it's more important in people that have not biospheric values than in the other people that have. Another aspect that is important, all we know that, is the context. Context factors include special and structural, economic and cultural factors, institutional arrangement, and access to technology, products, service, and information. On the one hand, such context factors may affect behavior directly by influencing the opportunities and constraints people face in defining the costs and benefits of different actions. And on the other hand, making behavior harder or easy to carry out. So the context encourage to change the behavior. So context can be an important factor also. And another aspect is community matters. It's my last topic. And I would like to talk a little bit about the importance of community initiatives, bottom-up initiatives, and tailored approaches. So, bottom-up initiatives or community initiatives show in different case studies around the world the importance of the community involvement in the change behavior. So when we ask, for example, in this study, when we ask the motives to be involved, respondents rated financial and environmental motives as more important than communal motives. But initiative involvements are strongly related to environment and communal motives, while financial motives were not. So community involvement are an important factor, but people is not aware of it and have an impact in behavior. Another aspect, another study, individual pro-environment motivations were only related with the intention, pro-environment intention, but the initiative involvement, the membership and identification was generally related with intention, but also with the behavior. So the pro-environmental, the individual pro-environmental motivation are only related with intention, but the community involvement are related with intention and with the behavior. So with the correct behavior to a pro-environmental behavior, of course. So the same in some organizations. This is my company is green, so I the idea is the relationship between corporate environmental responsibility and pro-environmental behavior are mediated by this self-identity environment. So the relation between corporate environmental responsibility and self-report pro-environmental behavior was stronger among those with moderated to weak biosphere values. So again, the community initiatives, the group influence are more important in the people that don't have biospheric values than in the people that have it. And finally, the importance of developed approach that are related with the community that are involved. So tailored approach are called for taking into account individual and social cultural difference and targeting key factors motivating or inhibiting the behavior of the relevant people, and especially to take into account social values and identities. I remember the Danish wind example that Katie showed before, and the importance of the historical familiarity, the relation between the wind and the old mills as an important aspect, this continuity in the identity and in practice for to change behaviors. I have another example in Évora, where is my university. One important aspect of the identity of the city, of the residents of the city, is the cleanliness of the city. It is a white city, and the cleanliness is a very important aspect, dimension of the identity. And in a recycling campaign, this characteristic was used to increase the involvement of the people and increase the motivation to participate in this recycling campaign. So, individual environmental values are important predictors of environmental behavior and beliefs, but it's important to include also group values, group influence. Group values can be used to promote pro-environmental action, especially in people with low pro-environmental attitudes. And participation in community environment initiatives have more impact in the behavior. Finally, participation in community environmental, I already said it. So to design tailored initiatives based on individual and group differences values are very important. So thank you very much for your attention.
Thank you, Fatima, for a very interesting presentation. Now we got into a bit of the psychology, which Suani asked us to go through. So, yeah, and then let's go for our last panelist, which also is a psychologist, Professor Sigmar Malvesi, which is from the Institute of Psychology of the University of São Paulo, and is the coordinator of the project, which I mentioned here at the RCGI. Okay, very welcome, Professor Sigmar. We are having a little issue here with the camera, so we're going to adapt here, which I'm going to put this computer just in front of Professor Sigmar so that he can give his words. Please. There you are.
Thank you very much, Kari, for the introduction you gave and for the organization of this very interesting panel, very interesting discussion in which we have analyzed several distinct features of our big issue. And now I probably will finish this presentation with another issue implied in our engagement towards sustainability, which is leadership. Okay, climate change and the risks they expose are fast rolling down snowballs, dragging most knowledge fields and institutions into their path. The prevention and mitigation of those risks rely on changes deeply intertwined in society's structures, such as lifestyles, economic, cultural, and technological equations. That complex interdependence between societies, mature structures, and necessary interventions in energy equations forecast the prevention and mitigation of those risks as a long-term revolution-like movement. The crucial target of that movement is the replacement of fossil by clean and sustainable energy. Being apparently an enterprise bounded to technical changes, that replacement encompasses coordinated activities through shared economical, technical, and political and cultural projects, multidisciplinary and ideological interlocution, individual habits, and institutional strength to meet the strong and disguised resistance to the redesign of both routines and matured structures and equations. The replacement of fossil energy demands interventions ranging from individuals to institutions and public policies. Its accomplishment is feasible and carried out through technical changes, but the acceptance of these changes and their effects are mediated by the public acceptance or resistance to the replacement of fossil energy. Although the axis of that replacement is grounded in technical solutions, their implementation requires acceptance and legitimacy of the short and long-term changes on the part of individuals, communities, institutions, and chiefly governments. All individuals, groups, and institutions are co-protagonists of these changes, a condition which requires their acceptance of the change itself and the enactment of their adaptation to new existence conditions. That acceptance and enactment rely on individuals and collective creativity, behavioral commitment, and steady cooperation with the planet's sustainability. Being a sort of social-technical enterprise, the prevention and mitigation of the environmental deterioration are matters of cultural movements, of re-education of society, of multidisciplinary knowledge, multitask performances, and long-term endeavor, the achievement of which rely on a steady coordination of intertwined technical actions and continuous care of their acceptance and legitimacy. Coordination and legitimacy are outcomes mediated by the public perception of those changes, of the actions required, and of their effects where they are demanded. That mediation does not spring up spontaneously, even when strongly supported by consistent scientific research and institutional demands, as recently seen in our experience in the COVID plague. Affective and cognitive insecurity, pragmatism, individualism, consumerism, and denialism are relevant obstacles to people's acceptance of the role of environmental sustainability protagonists. These hurdles are rooted in the intersubjective context where public resistance finds its nest and is manifested through all kinds of rationalization and opposition to one's commitment to the replacement of fossil energy. Requiring coordination of socio-technical interventions, prevention and mitigation of climate hazards pose leadership as a crucial instrument for their feasibility. Leadership is probably the oldest human instrument. It is hardly a serialized tool and is far from easy replication, as some technologies are in distinct places. Leadership is a handmade power, a kind of artisanship, a contextualized intervention. The power of leadership is built in the social interaction and therefore is not a permanent trait of individuals which they may take with them wherever they go. The influence of leadership is a property of the relationships between individuals built interacting with each other. The grammar within which leadership is constructed has not the same rules and norms in distinct groups. Latin Americans and Asians being built that power grounded in their respective context with distinct resources. As such, leadership is a power over others which requires sustainability in every new demand. It is rebuilt and sustained in social interaction where cooperation is required. The mechanism of that power has been assumed in psychology as the management of intersubjectivity through the social interaction. Its components, such as meanings, values, and beliefs, are sensitive to individual and social perceptions. The environmental leadership, as required by the coordination of the replacement of fossil energy, is the creation of competencies for cooperation on that enterprise. The replacement of fossil by clean and sustainable energy requires the construction of these competencies, which is the construction of environmental leadership. The forcing interventions in greenhouse gases depend on integrated environmental leadership aimed at people's capacitation for being climate change protagonists. That is the identity expected from now on, on the part of everybody. There has been here in Brazil some interesting investigation about that here called green identity. That capacitation is a long-term enterprise and sensitive to the oscillations of the public perception. Being this planet our common home place, those oscillations require consistent and continuous investigation, because today social interaction and the construction of the leadership power are heavily impacted by the social networks, which the economy of influence is enacting through interventions in the intersubjectivity and in the subjectivation processes. The recognition of climate changes, the legitimacy of technical solutions, the quest for cooperation towards environmental sustainability and solid commitment of all protagonists, the green protagonists, as we have called here, are targets which mediate the successful achievement of the replacement we are looking for. The subjective changes comprised in these targets are also sensitive to the power of leadership, which has been and it will be a strong instrument to bring about not only legitimacy of sustainability changes, but also the inner energies, as Hippocrates, the Greek thinker of centuries ago, said about human subjectivity. The inner energies such as motivation, ideals, and behavioral commitment as required by long-term legitimacy of the replacement of fossil energy. Thank you very much for your attention.
Thank you very much, Professor Sigmar. Thank you all. Well, I'm sorry, we have very difficult technical problems here, so we go ahead the way we can. Well, thank you very much for all the panelists, were wonderful approaches. Let's just do a quick round here in some of the questions, maybe with how could we develop a sustainable mindset? Rocio, maybe you could start because we don't hear you for a long time. So if you can start just sharing, how do you think of hearing all these things? What could be one or two hints of interesting ways to develop a sustainable mindset?
Well, first of all, thank you again to you and all the panel. All the presentations have been very, very interesting. I think that maybe just couple of things about how do we develop it. We have been talking a lot across the presentations of how we have to include stakeholders, different methods, different ways, different things to consider. We have talked about contextualization, which is really important. I mentioned it, Fatima did as well, Kathleen. But we have not talked very much about the difference of age. And I think this is an important area that we are forgetting. Now, when I was a student at university and we started to talk about sustainability, we were talking about the next generations. So now my students and the other students, they are supposed to be the next generation. And honestly, it's not happening. So we have to rethink about what we have to do to involve this. And we're talking here about a selected group, let's say, if we talk about students. But if we really want to talk about the overall population who we need to bring into this type of projects, maybe we should really think about how we can have access to, or how we can lead them to have access to some more information. We talk about an era of information, but it's probably the wrong information we are giving. So it was just mentioned a lot by Professor Sigmar, a lot of consumerism, many things that are not maybe the exact path that we need to reconsider again some of these issues on sustainability. So I would say maybe we need to rethink first how we provide the information and which is the relevant information we need to provide. I really don't think that could really be a mind change, but at least we can restart again. Remember that in the 70s, there were loads of campaigns about environment, and they seem to have been forgotten. We have to bring back informal education. And in Europe, you would think, everybody is really conscious. Not necessarily. We have to really go back to some of the basics on this informal education to try to be wider in terms of who we are going to reach out and which are the key messages. I think these two would be a way to start the discussion, let's say. I will leave it there so we can all have an opportunity. Thank you, Karen.
Thank you very much, Rocio. Who else would like to jump in with their thoughts? Go ahead, Kathy, please.
Thank you. And I'm going to take my hand down, my virtual hand, that is. Can you hear me? Yes?
Yes, perfectly.
Okay, thank you. I think Rocio raised some really excellent points in addition to others on the panel, and just building on the idea of learning and differences across ages. I would like to say also, I think we can consider that in terms of the influencers that relate to those different age groups. And so I would suggest that we could have different influencers. For example, if the political leaders of all our countries would ride their bicycles to work every day and have clean energy powering their palaces or their homes, and better yet, small homes like the rest of us, they could be demonstrating in real life, in real terms, and fostering the learning with leadership examples for the rest of the community. In terms of the differences across age groups, wow, just imagine if sports stars were doing the same, and musician artists, and through their various channels, whether it's social media or other means, providing ways for people to learn with them. I think that alone could be a great game changer. I'll stop there.
Thank you. Thank you very much. Yeah, good thoughts, Kathy. There is, I just wanted to mention, there is a comment here from somebody. I don't know if I'm going to say the name correctly, Sir Kirkis, and here it's got very much to do with what we are talking about. They said there's multiple opportunities for a just transition, including reskilling of human resources, starting even from the university education options that are provided to the new classes, and repurposing the technical skills in the labor force, such as between drilling and geothermal energy. What is the role of universities in ensuring the needed skills upgrades for the renewable energy transition? Who would like to go for that one? Sueni? You want to make any comment on that? Yeah, please. There you are.
I think that in the university, we also have to work a little bit with dissemination of information. We see that the students are interested on energy transition, on renewable energy. When we discuss the subject, they always are interested, but there is still a lack of information. This is reflected in some kind of behavior of the students. I think that we should work to develop further this kind of capacity building, because people listen about energy transition, about renewables, but it's something like someday it's going to happen. And it's important to realize that this is something to be done now, that we have an urgent, that this have to be developed now because of all the issues related to climate change.
Thank you very much, Sueni. And considering that we have to do this now, it means that we have to work with behavior, right? So a lot of this, the people, they understand, okay, we have to go to renewables, but I don't have to do anything about it, I don't have to change my behavior. And how do we sensibilize the people in order to, that's with your behavior, that's what you're doing today, and with the options or with the choices you do. So what do you think about that? I saw a hand up, was it? No.
It was me, Karen, but it was more related to the previous point.
Okay,
maybe
great.
if you want to allow maybe Fatima or Sigma to speak,
Fatima,
and then I'll come back.
Could you jump in, because behavior is with you, right?
Yes. I think it's very difficult, of course, we know that, but I think it's important conscientize the people to the impact of their behavior. We don't. We think that we are worried about environment, but in fact, we maintain our traditional behaviors. It's very difficult now in Europe with the crisis of energy. The people don't want to change, don't want to have in the Central Europe the houses so hot as they used to have. So it's very difficult to change the behavior, because the people are it's difficult to change. So perhaps when we understand the impact of our behavior, we have like this, to don't use plastic. But it's important to understand that this kind of things that are sometimes fashioned, have impact also in the environment, and what kind of impact they have. And when they are old, not so nice, if we don't use it, this have impact in the environment. So perhaps it's especially in the universities connected to these two questions, where the people are more informed, have more education. It's important that people know the impact of these small behaviors, because all our behaviors have impact on the impact on the environment, and we can't change some behaviors for other behaviors that also have an important impact in the environment. So I think it's a very difficult question.
Probably that's why it had so much discussion, you know, and so much of these interesting presentations that you brought, because really it is very challenging, and for a long while they've been focusing more on the technology side of the kind of the transition, but less on the behavior, you know. So now we really have to dig into this together, because technology, economics, and environmental and people are all together. If you don't do it in one side, the other side will fall, you know. So it has to be done together. So I would like to go to you, Professor Sigmar, to ask you about how do you think, what's the main focus that leadership can do, you know, in order to deal with this kind of the challenge of the behavior?
I think that we are doing a lot of things, really a lot of things, but we are doing them, but they have not been as fertile as we have expected, okay? Because it lacks coordination. One of the main problems of our present day society is the fragmentation of events. The fragmentation of events turn people with a narrow mind, because they see less the totality and see small pieces of totality. I think that I will come back to an author I have studied many years ago and still do, Hannah Arendt, and to come to her ideas about a big problem like this. First, yes, we need to coordinate our dispersed initiatives and to concentrate to give them power, okay? Because many times the initiatives are very good, but they don't have the power of transformation, okay? And we need to fertilize that power. What to do in order to develop a leadership in that direction? I think two things. First of all, collective thinking, collective critical discussions, which, according to Hannah Arendt, is the political power that we need in this enterprise. And the second is to involve and to focus the socialization and re-socialization processes that is going on always in society, in order to put sustainability as part of the routine. Routine has a big power of transformation, and we need to use that power to involve that power of routine. So two things to your question, Karin, is the collective thinking of our sustainability, and the second is to put it in our routines.
Thank you very much. I think that's very insightful, and a very insightful thought, and I think that's, you know, very related to what each of us can do. Right. So for us to go to the closing, because the presentations were very interesting and we've got a little time here only for finishing our discussions, Like we are a multidisciplinary team, I would ask you then to give your ideas about how can a multidisciplinary approach contribute more effectively addressing the challenges and opportunities of sustainability that we are talking about. So thinking that here we are a group of people that have engineering, people from administration, people from international relations and psychology, everything. Oh, so there's a broad view, people from energy and bioenergy and this kind of thing. So how do you think this multidisciplinary approach can contribute?
Well, let me start with the first answer to your question. I think that, first of all, multidisciplinary is an area in which we recognize our ignorance. We know a lot, we may know a lot about one topic, 2 or 3 topics, but today interventions in society do not allow superficial and fragmented interventions. So the acknowledgement of that condition obliges us to dialogue with other fields. Today, I am convinced, really convinced, that organizational psychology, which is my field, main field, organizational behavior, it cannot present solutions alone to anything. So I need to find partners from other disciplines. And that is the way we need to go on.
Thank you very much. Rocio, would you like to mention and your closing thoughts?
Thank you, Karen. I think we have moved in the last, I would say, even a little bit more than 10 years into multidisciplinarity, probably even a little bit more. But we are still working in silos. I think that is really the problem. That there is not really this integration. We should be talking about multi-integration. And the other thing I was also thinking about on these issues and with the behavior and these aspects of champions, let's say, or giving some having some influencers. I think that we need also to share more responsibility. I mean, it's not just the policymakers; it's also us as researchers, as citizens, as family members, as communities. So this share of responsibility, I don't think it's really widely spread. So that would be another issue. And for this share of responsibility, we need to have more co-development. We cannot just give things to people to say, this is how we have to do it. We really need to co-develop. We really need to co-design many of these solutions together, because then there will not be acceptance, there will not be uptake of the solutions. So we really need to start to moving into these directions. We have some few examples, but because it's always at a very level academic communities, so we really need to expand it and really enroll with other different types of stakeholders. So, thank you.
Thank you, Rocio. Kathy, do you want to give your thoughts on that, please?
Sure, absolutely. So I would say to the question about multidisciplinary approaches, and I would also add cross-sectoral approaches, we need to remember that there are strengths and weaknesses coming from each of those domains. And if done well, we can be harnessing the strengths across all of them to advance a better solution than if we're working in parallel or separately. And so the key is, who are the integrators, or how is the integration happening? And I think that really depends on an individual community. not only the people within that community, but how they interact and govern themselves. And so that's where the all-important psychologists on our panel here have some very big opportunities to keep us focused on the best ways forward in that space. Thanks.
Okay, wonderful. Let's hope working together that we can achieve that. Talking about psychologists, can we hear Fatima?
I think that my colleagues already say very interesting things. And in my opinion, the question is more than a multidisciplinary approach, is work together and find solutions together, not only different approach, but work together, especially work with the community, with the different levels of government and so on. So I think it's very difficult and important situation. So I think we need to work, the different levels need to work together to find not a solution, but different solutions to achieve the big solution.
Wonderful. Thank you very much. Swani, your closing remarks here about this topic?
Well, as I said, I'm not a psychologist, but I would like just to recall one issue. The importance of the participation of media in general. Media could help a lot in dissemination information and helping changing behaviors. And we see, at least in Brazil, we see some tentatives, some experience of media to explore climate change issues and renewables and talking about changing behaviors. And this is not so much well done or so much coordinated. And I think this could be explored more. University could use it more for disseminating information and to try to change a little bit behavior.
Thank you very much, Swani. Thank you very much, all. I think we've got a very good set of ideas of ways to go forward, to move forward. We needed another 2 hours to discuss this, really, because people are complex, we are complex, and so it's very challenging. Well, but I think time has come, and probably the coordination will tell me we have to cut off. So I will finish off thanking everybody for participation, for the panelists, for the wonderful ideas shared over here, and for the committee for inviting us and receiving us to discuss so important subject as the social perception and behavior of people, and how we involve people in this. So thank you very much, each one of you, Rocio, Kathy, Fatima, Suani, and Sigmar that came over here so that we could do it together. Unfortunately, we had technical problems over here, but we were able to handle it. And thank you very much, Rita, and all the committee of the conference organization.
Thank you.
Thank you, Karen, and thank you for all panelists, Kathy, Rocio, Fatima, and Suani, and Sigmar. It was very, very useful and successful panel. I think for me it was very, very nice, and all of you have my gratitude for this panel. And now I have to finish this session and the third day sessions and invite all of you to come tomorrow for the last day, another panel concerning energy transition and decarbonization. I think will be also very interesting and very helpful for everybody. Then you are invited to come. And for all the attendees, don't forget to go to the virtual sessions, ask questions, interact with your colleagues and everyone. So see you, all of you, tomorrow. Thank you very much for the day.
Thank you. Bye-bye.
Thank you.
Bye-bye.
Bye.
Thank you.
Bye.